Half the cost, double the performance. ScyllaDB just launched a cloud service that makes DynamoDB look like a ripoff.
Wait, they're claiming double the performance at half the price? That's literally a 4x improvement. How is Amazon letting this happen?
Because they're using a completely different architecture that scales in seconds, not minutes. And if you're paying for DynamoDB right now, you're about to feel really stupid.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into ScyllaDB's new cloud challenges DynamoDB cost performance.
But first, let's cover today's top headlines.
There's a fascinating new development in infrastructure automation that just dropped on Archive. Researchers have created TerraFormer, a neurosymbolic framework that uses LLMs to automatically generate infrastructure as code.
Wait, so this is like having AI write your Terraform configs? How does it ensure they're actually valid?
That's the clever part. They're using policy-guided verification feedback to fine-tune the models. So it's not just generating code blindly, it's learning from formal verification processes to produce compliant infrastructure definitions.
That could be a game changer for platform teams drowning in IaC requests, though I'd want to see how it handles complex multi-cloud setups.
Speaking of infrastructure security, Wiz Research just uncovered something pretty alarming. A supply chain vulnerability compromised core AWS GitHub repositories and could have threatened the AWS console itself.
Hold on, someone got into AWS's own repos? That's huge.
Yeah, it exploited code build configurations. The scary part is this shows how even the biggest cloud providers can be vulnerable through their supply chains. Platform engineers need to be auditing not just their code, but their entire CI/CD pipeline.
Especially with how interconnected everything is now. One compromised dependency and your whole platform could be at risk.
And that brings us to our third story from DZone about securing ML pipelines. They open with this wild story about a healthcare startup whose fraud detection model failed, possibly due to a poisoned training pipeline.
Poison training data? That's a new attack vector I haven't thought much about.
Right? The article argues we need to apply DevSecOps principles to ML ops. It's not just about securing the model deployment, but the entire ML lifecycle. Data ingestion, training, validation, everything.
Makes sense. As platform engineers start supporting more ML workloads, we can't just treat them like regular applications. The attack surface is completely different.
That covers today's headlines. Now let's get into our main story. So ScyllaDB just dropped something that's making some pretty bold claims. They're saying they can match DynamoDB's performance at half the cost. And they're not just saying it, they're actually guaranteeing it.
That's a huge claim. DynamoDB is basically the gold standard for managed NoSQL at scale. What's their angle here?
They're calling it ScyllaDB X Cloud, and the key innovation is this tablet-based architecture they introduced in version 6. Instead of the traditional ring architecture that most distributed databases use, they're breaking everything into these 5-gigabyte chunks called tablets.
Wait, so they're moving away from consistent hashing? That's been the standard for distributed databases for what, like 15 years?
Exactly. And here's why it matters for platform engineers. They're claiming they can scale from 100,000 operations per second to 2 million while maintaining single-digit millisecond P99 latency. No performance degradation, no over-provisioning.
But hold on, that kind of scaling usually requires some serious trade-offs. What about consistency? What about operational complexity?
That's what's interesting. They're targeting companies like Discord, Disney, and Starbucks who are already using ScyllaDB for fraud detection and real-time workloads. These aren't exactly small-scale operations.
So they're not going after the general-purpose database market? They're specifically targeting high-throughput, low-latency workloads?
Right. And the cost angle is fascinating. They're running on ARM Graviton4 instances, those IaC and IaGE instances, and claiming they can compress data up to 80%. That's not just storage savings, that's network transfer savings too.
80% compression sounds optimistic. What kind of data are we talking about here?
Coming up, we'll dig into exactly how they're pulling this off technically, what these tablets actually do differently, and whether this 50% cost guarantee is actually realistic for real workloads.
All right, so let's get into the technical meat here. How does this tablet architecture actually work?
So traditionally, distributed databases use consistent hashing to distribute data across nodes. You hash your partition key, it maps to a token on the ring, and that determines which node owns that data. The problem is, when you need to scale, you're adding or removing entire nodes, which means massive data movement.
And tablets solve this how?
Each tablet is a completely independent unit. about 5 gigabytes of data. When a tablet fills up, the system just creates a new one. No rebalancing the entire cluster, no massive data migrations. New tablets can join the cluster and start serving traffic in seconds.
That's clever. So instead of thinking about nodes as the unit of scale, you're thinking about these smaller chunks. But doesn't that create more metadata overhead?
It does, but here's where it gets interesting. They're claiming 90% storage utilization compared to the industry standard of 70%. That's a 20% improvement in efficiency right there. And because tablets are independent, you can pack them more densely without worrying about hotspots killing an entire node.
What about the compression claims? 80% seems really high.
They're using a combination of techniques. First, they're leveraging the column nature of their storage engine. Similar data types compress better when stored together. Second, they're doing this on Graviton4, which has some serious SIMD capabilities for compression algorithms.
Oh, that's smart. So they're not just compressing for storage, they're compressing for network transfer too.
Exactly. They claim 25x faster data streaming with compression. Think about what that means for cross-region replication or disaster recovery scenarios. You're moving a quarter of the data over the wire.
But compression has CPU overhead. How does that play with their latency guarantees?
That's where the Graviton4 choice becomes critical. These ARM chips are incredibly efficient at these kinds of workloads. Plus, with their shared nothing architecture, each core can handle compression for its own tablets without coordination overhead.
Speaking of architecture, how does auto-scaling work with tablets?
This is one of the coolest parts. You define your CPU footprint, and the system automatically scales storage to match. No more guessing at IOPS or throughput units like with DynamoDB. If you need more performance, add CPU. If you need more storage, it happens automatically as tablets fill up.
That sounds almost too simple. What about hot partitions?
Tablets can be split and migrated independently. So if you have a hot partition, you can split just that tablet and spread it across multiple nodes. You're not reshuffling your entire dataset.
That's actually really elegant. But what about consistency? How do they handle replication with tablets?
They're still using their standard replication factor, typically 3 replicas. But now each tablet has its own replication group. This means you can lose nodes without losing availability, as long as you don't lose all replicas of a specific tablet.
What about operational complexity? This sounds like a lot more moving parts than a traditional ring architecture.
That's the trade-off. More metadata to manage, more granular failure domains. But they're betting that the cloud service abstracts most of this away. Platform teams get the benefits without managing the complexity.
And the node sizing flexibility. From 2 nodes to 128 cores, that's pretty unique.
Yeah, most managed databases force you into specific instance sizes. This granular scaling means you're not paying for capacity you don't need. Stick around. We'll break down exactly when this makes sense for your workloads and what questions you should be asking.
So let's talk practical implications. When does this actually make sense for a platform team?
First, you need to understand your workload profile. ScyllaDB X Cloud is optimized for consistent high-throughput operations. If you're doing millions of small reads and writes, think IoT data, gaming leaderboards, financial transactions. This architecture shines.
What about more traditional workloads, like, say, a typical e-commerce platform?
That's where you need to be careful. If you have highly variable traffic, Black Friday spikes followed by quiet periods, you might not see the same cost benefits. DynamoDB's on-demand pricing might actually work out better for bursty workloads.
What questions should platform engineers be asking before making the switch?
First, data model compatibility. ScyllaDB uses CQL, which is Cassandra compatible. If you're coming from DynamoDB, that's a migration effort. Second, consistency requirements. ScyllaDB offers tunable consistency, but it's eventually consistent by default.
What about operational tooling?
Critical question. What's your monitoring stack look like? ScyllaDB has Prometheus metrics built in, but you'll need to retool your dashboards. Also, think about backup and restore. They handle it differently than DynamoDB's point-in-time recovery.
The compression benefits seem like a no-brainer for anyone with large datasets, though.
True, but remember, compression ratios depend on your data. Time series data, you'll probably see those 80% numbers. Random UUIDs and encrypted blobs, maybe 20-30%. Test with your actual data.
What about the 50% cost guarantee? How does that actually work?
They're comparing equivalent workloads, same throughput, same storage. But here's the catch. You need to commit to reserved capacity to get those prices. If you're using DynamoDB on demand, the comparison gets murkier.
Any gotchas platform teams should watch for?
A few. First, geographic distribution. DynamoDB has points of presence everywhere. ScyllaDB X Cloud is still building out regions. Second, ecosystem integration. DynamoDB has deep AWS service integrations that you'll need to replicate.
What about the future? Where's this headed?
I think we're seeing the beginning of specialized database services. Instead of one-size-fits-all, we're getting databases optimized for specific workload patterns. ScyllaDB is betting on the high-performance segment.
And tablets as an architecture pattern, I could see other databases adopting this.
Absolutely. The ability to scale granularly, maintain high utilization, and avoid massive rebalancing operations, those are universal benefits. Watch for other distributed databases to move in this direction.
So bottom line for platform engineers?
If you're running high-throughput workloads on DynamoDB and your AWS bill is painful, ScyllaDB X Cloud deserves a proof of concept. Start with a non-critical workload. Measure everything: latency percentiles, cost per operation, operational overhead. The tablet architecture is genuinely innovative, but like any technology decision, the devil's in the implementation details. And here's the thing that really struck me. We're moving from an era where you picked a database and lived with its limitations to one where databases are adapting to your specific needs. That's a fundamental shift in how we think about data infrastructure. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.